So if you're absent or you missed this part of the notes for whatever reason, I'm going to do a very brief overview of section point 1, solving linear systems by graphing. So again, this is not the full set of notes that the class got, but this will get you going if, again, you were absent or you missed the notes for whatever reason. Refer to the book for more examples and just simply more information about the section. So this is a very brief overview. So solving linear systems by graphing is not anything new per se. It's an additional step to what we've been doing so far in chapters 5 and 6. So it starts out with a pair of linear equations, for example, and this is example 1 from your book. So you can refer to it that way as well. So they give you a pair of equations, linear equations. So that's equation 1 and that's equation 2. Now, to solve a system of linear equations by graphing, essentially what happens is you need to find an ordered pair, so an x and y. So an ordered pair which looks something like this, x, y, with x and the y obviously being numbers, that will work for both of these equations. This one order set will solve both equations. If it does, then you have a solution to your system. So again, the system consists of two or more linear equations with the same variables. So here we go, two equations and they have the same variables. Both have an x and a y. And to solve one of these systems, you need to find a very specific, and it's almost always going to be one, especially for two, set of ordered pairs that will work for both. Not just one, they have to work for both. And there are 3 ways of doing it. Today in 7.1 we're going to learn the graphing method. This is the longer method, but you got to know it, so this is the first one we're going to go through. So graphing involves graphing. So what you have to do is you have to graph both equations because they give you two linear equations, and we know how to graph linear equations. If you remember from chapter 6, we learned this, the slope-intercept form, y equals mx plus b. This was the easiest way to graph an equation. We learned a few methods, we learned 3, but of the 3, this was the easiest one and the most accurate. It was like accuracy and ease in one package. So we are going to use this method to solve both of these equations. So we're going to put both of them into slope-intercept form. So in slope-intercept form we're solving for y. So I'm solving for y here by getting rid of everything that's not y on the left side. So I'm going to get rid of x by subtracting x from both sides. I get 2y equals 7 minus x. And then I want to get rid of the 2 by dividing, because the 2 is being multiplied by the y, the opposite. And that's what you need to do, is the reverse operation, is division by 2. So it gets rid of the 2 here, 2 divided by 2, that's 1. So 7 over 2 minus x minus 2. So we're pretty much finished with the slope-intercept form. Or I typically like to rewrite it so there are no fractions for the intercept, and the slope is more visible. I didn't really do anything, I literally just rewrote this problem to make it easier. Now that I have the slope, which is whatever's next to the x, the m, is in this case negative 1 over 2. Again, it's a little hard to see the negative 1 over 2 here, this is why I rewrote it, but it is what it is. The intercept, the y-intercept, the b, is whatever is all by itself, and that's the 7 over 2 or the 3.5. The 3.5 is just easier to graph than the 7 over 2. Same number, but perception. Now let's do the same thing to the other one. I'm going to isolate, oops, sorry, there we go. I'm going to isolate the y over here by subtracting 3x from both sides. Then I'm going to divide everything by a -2. Again, to get rid of that -2, I do the reverse. It's being multiplied, I divide it. So 5 over -2, I like to write my negative at the top on the numerator. That's a better way of writing it. It's not, doesn't really change anything, but it's a 5 divided by -2, so it's a -5 over 2. And -3 divided by 2, negative by a negative, that's a plus, it's a positive, 3 over 2x. And again, I like to rewrite my intercept as a decimal instead of a fraction, so it's a -2.5. 5 divided by 2, that's 2.5, so that's why. Alright, so for here my slope is whatever's next to the x, which is the positive 3 over 2, and my intercept is whatever's by itself, which is a -2.5. Now that I have these two pieces of information, I can graph, and that's exactly what I'm going to do. I'm going to graph both of these and then find where they intersect. That's the important portion. Now that I got my piece of graph paper, we can go ahead and graph. So I'm going to do my coordinate plane real quick. Since I kind of know what this will look like, I'm doing like a modified coordinate plane that's shifted to one side because I sort of know where it will be. Okay, so this is the first equation, and that's the one I want to start with. The intercept for the first one is at 3.5, so that's the y-intercept. So on the y-axis, I'm going to go up to 3.5. So that's 1, 2, 3, 4. So right in between 3 and 4, that's my starting point, the y-intercept. The slope is -1 over 2. So you go down 1 over 2. Interruption. So the slope is down 1 over 2. Down 1 over 2. Down 1 over 2, and you only really need 3 points to make an accurate graph, so that'll do for us. Now for the other equation, the intercept is -2.5, so it's going to be down here somewhere. So again on the y, always on the y. So 1, 2, 3, so 2.5 is right in between 2 and 3. The slope is 3 over 2, so up 3 over 2. 1, 2, 3, up 3 over 2. Then 1, 2, 3, up 3 over 2. And again, that's all you really need. Now we graph them. You can graph them individually, one at a time, or you can graph them right away at the same time. Kind of whatever works for you. This saves me some time, so I'm graphing both at the same time. So this is, and you really do need to be careful when you graph these points. It really helps if you are as careful as you could be. And the second one, alright, so now I got them graphed. First equation, second equation, and they intersect right over here. And that's my solution. And that's x at 3, y at 2. So that should be the solution for both of these equations in this particular system. So in the next video, I'm going to go ahead and plug them in, and we'll see if it actually is confirmed as the solution.